Have you ever wondered about FAIR data but found it a bit, unclear? No problem, because today we're demystifying FAIR. Findable, accessible, interoperable, and reusable. But here's the catch. When it comes to findable, finding scientific data isn't as straightforward as Googling a web page. Traditional search engines won't cut it, and you're probably not thinking in terms of web page searches. You're after something more specific, like the slope of a line or critical physical properties within certain ranges. If you're a researcher, you might be thinking, how do I catalog my data in a way others can effortlessly find, access, connect, and reuse it? Perhaps for purposes such as designing their own experiments or creating AI models. Enter nanoHUB, your solution to FAIR data challenges. How? Through SimTools, a cutting-edge declarative system. SimTools allows your data to be expressed in machine-understandable declarations and formats. Imagine your lab generates and analyzes experimental data, and with SimTools on nanoHUB, it automatically stores and organizes the data and analyses in a FAIR database. What's more, if you include detailed data about your experiments, you have a digital twin on nanoHUB. Magic, right? But SimTools isn't just for data analysis, it's your ticket to simulations too. When you run a SimTools-based simulation on nanoHUB, the platform works its magic, searching its vast database of results. If it finds a match, you get an instant answer. If not, your results are computed and added to the growing nanoHUB database. Now let's talk FAIR. Not only can results be retrieved by a SimTools signature, but they also can be queried using any input or output. This means users can browse the results database based on the properties they care about. And thanks to machine-readable formats, programs can query the results database through an API, providing powerful and customizable search capabilities. Consider Bruce. He's exploring PN junctions, running simulations with specific parameters. He finds what he needs, and days later, Daria, with a different interest, can access the entire results database, exploring it with her own data analytics program. Daria finds a run generated by Bruce's activity, delving into the details effortlessly. She even views the API code to understand how to retrieve the results. But before she dives into code, she uses nanoHUB's tools to explore results visually. With just a few clicks, she explores various combinations of parameters, gaining confidence in writing a data analysis program. And that's the beauty of nanoHUB. It creates a community passionate about scientific data where creators and consumers seamlessly coexist. Such a community is empowered to learn from each other, amplify their collective efforts, and even use AI methods to learn from the results database and explore new science. You might be wondering, how secure is this database? Rest assured, the identities of Bruce and Daria are shielded from each other and from the nanoHUB community entirely, as are the traces of their activities. Only the resulting data are made public as part of the database, and then only if Bruce or Daria opt to allow nanoHUB to save and share it. So if you're ready to make your data FAIR without breaking a sweat, then let nanoHUB make it FAIR for you so you can focus on the science instead. Visit nanohub.org or drop us a note at info@nanohub.org.